Welcome. This video covers the common data object called a list in R. We've been talking about these major data types, so these data structures in R that we commonly use with data. We talked about the vectors, one-dimensional, but everything is of the same type. Data frames being this great object that's useful for housing most of our data sets. Each one of the columns representing a vector, but then we have each one of those vectors having the exact same length, so we have a certain number of rows. So that's a two-dimensional object. Well, the last one we're going to talk about here is the list. Lists come up quite a bit. Many of the functions that we can run will often return a list. And so we need to understand them and be able to access different pieces of them. So a list is one-dimensional, but you might notice that it's under the heterogeneous column within this little table. And that's because a list is one-dimensional, so there's an ordering, first, a second, a third, a fourth element, etc. But each one of those objects, each one of those elements can actually be a completely different type of our object. So it's this really super flexible type of data structure. Here's a little visual to help us understand what a list looks like in our heads. Again, there's an ordering. So this is one-dimensional, right? 1D. There's only an ordering in one way. There's a first element, a second element, and a third element. But each element itself can actually hold a completely different type of R object. So this one here would be a vector in the first element. This one would be a data frame. And this one would be another list. So you can have nested lists, if you will. So they're the super flexible type of object for holding data that doesn't sort of fit nicely in a rectangular structure. How do we create our own lists? Well, there's a list function that does that. And so I can do it just like I did with a data.frame function. I just use list, and then I separate by commas what I want each one of the elements to be. With the data frame, I put my first column, my second column, my third column. Well, it's the same idea with list. I'm going to put my first element, my second element, and my third element. And so here my first element is a vector 1, 2, 3. So when I print out my list, you can see here it's just 1, 2, 3 as the first element. The second element is R norm. We saw this in one of our videos. So R norm produced random values from a standard normal distribution. So we're going to get 4 of those values back. So in my second element here, I get those 4 values. In my last element, I'm going to create a character vector with 2 things in it, an exclamation point and a question mark. So my third element, I see that character vector. So again, this type of data is not conforming to a nice like two-dimensional structure. So we need something like a list to house it together. Now, just like with data frames, we are able to add sort of nice names to these elements so that we can call them in an easier fashion later on. Here I'm going to call the first element seq. SEQ. I'm going to call the second element norm values, and the third one punctuation. And you can see that this actually changes the way that it prints out, right? Before, it printed out with those double brackets representing the first, second, and third elements. And now it's printing out using the names that we gave it instead. So a much better way to print this stuff out. How do I access my different elements? Well, this is a one-dimensional object. We saw square brackets were super useful for investigating the elements of a vector, an atomic vector, which was one-dimensional. So let's go ahead and look at how we can use square brackets to return things from our list as well. If I have my list that has these 3 elements in it, I can use square brackets and say 2:3 to say I want to return the second and third elements of that list. So just like before, same idea. I can use double square brackets, though, which is kind of interesting, to grab a particular list element and return that in a simplified form. So let's look at a couple examples. If I look at my list that I have up here and I use a single square bracket and I put 1 there, it returns this first thing, but it returns it as a list. Okay. So what I'm actually getting returned here is not a vector with those 3 values. It's not simplified. It's returning a list with 1 element, and that 1 element is a vector of length 3. However, if I use double square brackets, this returns it as a vector. So it simplifies it if possible. And so in this case, my list bracket 1 returns a vector with just 1, 2, and 3 in it. So different types of data structures are being returned with a single square bracket versus a double square bracket. And one thing that you can do if you want to sort of simplify your code and not have a bunch of intermediate steps is you could say, I want to return just the second list element, so just the norm values. And since I know that that's going to return a vector in this case, if I just wanted the third and fourth elements, I can go ahead and just add square brackets after that. And it's going to say from the object that gets returned right here, Now just grab the third and fourth elements. And so you might see code like this somewhere and it might look confusing, but if you just break it down into the different pieces, you can hopefully understand what's going on. Now, we gave these things names, right? Whenever we created our list, we said, let's give them names so it looks a little bit nicer. And as they are named, we can actually use those names to call the elements as well. If we look at the structure of my list, we can see that this is a list of length 3, and these are the different names corresponding to each one of the list elements. And just like we did with data frames, we can use that $ operator to get back one of those elements. So here I'm doing my list $seq, and it's returning the simplified version, so just a vector of this. So this is going to simplify. Right. And so occasionally you're going to come across these pretty complicated list elements. And so these lists can have lists within them, right? We saw that the first element can be anything, right? It can be a whole nother list within there. So what I'm going to do here is create a new object called big list. And this big list is going to have in its first element that list of length 3, right? This was a list of 3 things. So within the first element of big list is a list itself. And then the second element of big list is just a vector 1 through 10. And oftentimes you're going to need to parse through objects that look like this. And it's going to be a little bit confusing. But again, this structure function is super, super useful for figuring out what you're dealing with. If I look at the structure of big list, we can see here that it's a list of 2 things. And this is the first level of the list, right? So these are the 2 list elements of big list, first and second. The first element actually has a list itself. And here are the 3 elements of those. The second just has an integer vector of length 10. And so if I want to get access to some of these values within the first list element, I can do big list $first. And again, that's going to simplify what it returns. So it's going to simplify it to just return the list that has these 3 things in it. So I get sequence, norm vowels, and punctuation. And so if this is returning a list itself, I could actually keep going with my $, right? I could say big list $first, and then $seq. And that's just going to return me the first list element of that thing. And so again, you might see this code and it might look really confusing, but if you just break it down and think about what it's doing in each one of these pieces, this is returning the first element of big list, which is a list of length 3. And now I'm going to return the seq element of that. And this is why it's a lot better to have names if you can, because this kind of thing here is equivalent to what we're doing here, but this is a lot harder to understand. So big list bracket 1 returns the simplified version of the first element. So it returns just the list itself, not a list of the list. And then I'm going to grab the second list element of what gets returned and simplify that. So this gives me the norm values. So again, use names if possible. Now, you might be thinking about these $ and what we did with data frames and saying, hey, those looked pretty similar. And when we ran structure on a data frame, it looked pretty similar to what we had when we ran structure on our list. Well, there's actually a big connection here. A data frame is just a list of equal length vectors. If you look at the structure of my list here, just that first list object we created, this is a list of length 3, and again, you can see that the named values are given here. Well, if I run structure on a data frame, Iris is a built-in data frame, so you have access to this. If I look at the structure of that, I see that it's a data frame. It's not a list, but the way it shows it looks exactly the same, right? And so again, a data frame is really just a list of equal length vectors. So this is the first list element. Sepal width is the second list element, and so on. So a data frame truly is just a list with vectors of the same length. Which means that if I run something like type of, I can actually see this. If I do type of for my list, remember that type of returns the internal way that this thing is stored in R. So type of my list, it's a list. And type of Iris, even though it's class data frame, how it's stored internally is as a list. So that means that I can access different elements of data frames using the way that we accessed lists, right? So Iris bracket 2, notice that I don't have a comma in here. This is going to return the second list element. And what that means, well, the second list element was the sepal.width column, right? But I used a single square bracket, so it's going to return it as a list. So it's going to actually return it as a data frame. I'm going to use df for data frame, by the way. But if I use 2 square brackets, so I do iris bracket bracket 2, it's going to return this same thing, but it's going to return it simplified, right? And so it's just going to return the actual values of that thing. And this is equivalent to doing iris $sepal.width. So again, we can use the same kind of notation for a data frame that we use for a list. All right, let's jump into R and check out playing around with some lists. All right, so here we are in RStudio. Again, we're going to continue this previous program that we were writing. We're just going to do some list practice here. And we could use that list function to create our own list. But in this case, let's go ahead and run a function that's going to return a list based off of some computation. And so we saw this lm function just previously for a second. And this fits a basic linear model. And so we could fit the stopping distance for the car based off of the speed from this cars data set. Again, cars is a built-in data frame that has information about the speed of cars and their stopping distance. So we could fit a simple linear regression model based off of that. I'm going to store the output of this lm call in an object called fit. And you'll see up here that it creates a fit object that is a list of 12 things. And so we can click on fit if we want up here. And you can see the list elements. So again, this is equivalent to running the str function or structure function here. You can see it has a lot of stuff going on. But hopefully we can sort of read this at this point. We have a list of 12 items. And so the first $sign here, this corresponds to the first list level. So there is a coefficients object as the first list element, residuals, effects, rank, fitted, sign down to QR. Now QR is a little bit interesting. It's actually a list of 5. So now we have a nested list in there. And you can see that this first part has a bunch going on as well. And so this is a complicated object, but maybe we can parse through it a little bit. If you don't want to see all of the different elements of that list, you just want to see a little bit of a simplified version, you can do the structure on your object and then add in an additional argument. So if you put a space, a comma, and then a space when you're calling a function, and you hit tab, it will actually populate some more of the options that you have, some more of the inputs that you might put in for that function. And so one of these for structure is max.level. So if I put max.level equal 1, that's going to say I only want to look at the first level of list items. So I don't want to see like second level and third level, all that kind of stuff. So this is a little bit easier to read, but not all that much. But you can see that, for instance, here, the QR object now just says list of 5 and doesn't show me much more beyond that. So this is just a simplified version of looking at the structure. All right, how do we access different pieces of this? Well, let's go ahead and look at the coefficients of the regression fit. So we're just fitting a line, so we need an intercept and a slope term. So these are the estimated values of those. And so they're within this coefficients object, coefficients element of our list. So if I want to grab those, I can do fit $sign. And notice again that RStudio is nice. It populates all of the different named list elements. So coefficients is the one I want. I just hit tab. Now when I run that, I get back the simplified list elements. So just the vector itself corresponds to those 2 coefficients. But this is a list, so I can use things like a single square bracket. Remember that that does not simplify things. So what gets returned here is actually a list that has that vector in it. If I looked at the structure of fit bracket 1, this is a list of 1 element, and that element is a vector. If I did fit bracket 1 instead, remember that that simplifies it. That's the same thing as doing fit $sign coefficients here. And so I could do something like fit $sign coefficients. And if say I just wanted the intercept, I could put a bracket here and then a 1, because remember that what's getting returned here is just a vector of 2 things. So I can go ahead and dig into this thing a little bit further, send that to the console. I get just the intercept return. So lists can be pretty complicated objects, but hopefully with your structure command and the ways that we know how to access a list, you can parse through it and break it down a little bit. All right, to recap, we now have a decent idea about the major data structures that we're going to use. We have the vector, one-dimensional but very basic because it can only house things of the same exact type, numbers, character strings, logicals, that kind of thing. We have a data frame, which is great for 2-dimensional data, where each one of the columns represents a variable, and really each one of the columns there is a vector. And then we have a list, which is this one-dimensional object that is more flexible. Each element itself can be a different type of object. So what we'll do next is look at how do we actually read raw data into something like a data frame.